All right, so hi everybody. Welcome to the first talk of the test track at Black Hat 09. I'm Mike Tracy. This is Chris Rohlf and Eric Monti. We're here today and our talk is called Ruby for Pentesters. So that's us. So what we're going to talk about is why do we use Ruby to solve the everyday tasks that face us while we're on engagements pretty much every day. We talk about scripted pen testing. We talk about reverse engineering, dynamically, statically, network protocols, applications, and we're going to talk about fuzzing, which there's a good talk on fuzzing immediately after this talk in this room. So if you want to learn more about fuzzing, you should stick around for that. And then we're going to talk about integrating Ruby into the applications and tools you already know and love. So why Ruby?
All right, so everybody in the room here probably works in some way in security, or at least is interested in doing so. And in security, you find yourself with deadlines and complex problems to solve. So having a tool, a scripting tool, ideally, that is dynamic and flexible, and you're just to be able to tackle those everyday tasks is kind of a must-have. There are lots of tools out there. You know, we're not up here to talk about Python or C or Perl or PHP. We're here to talk about Ruby. But Ruby is great for this because when you code Ruby, you're usually building a library that you're going to use over and over and over again. You're going to have common problems and common solutions that you've already tackled. And again, this isn't necessarily unique to Ruby, but Ruby does have some unique features that really lend themselves well to this dynamic. So let me just go back for a second. When I'm talking about the specifics of what lends Ruby well to this dynamic tool set is that it's extensible, flexible. The object-oriented model allows you to create and modify classes without having to rewrite your code. You can do it on the fly with new projects. You can create bespoke versions of tools that you've already written for specific projects without having to copy over or rewrite code.
Yep. And as you can see, as we're going through the talk, the code examples are going to show you how we use Ruby to reopen classes and create mix-ins for things that already exist. And then we tie things together and hook stuff up really easily.
Right. We'll talk a little bit more about our approach as we go along too. So we're not alone in using and loving Ruby. You know, there's a whole track devoted to Metasploit this year. And Metasploit, I think I heard at some point, I don't know if this is still true, but it's like the largest Ruby application ever. Some other notable security tools that have been out and are in various states of use and repair are IdaRub, and I wanted to mention Ronin because it's actually an interesting developing project by somebody named Postmodern. That's what he goes by. But this list isn't as long as it should be, and kind of why we're up here is also that we'd like to, kind of create more interest and more involvement in Ruby. So if you walk away today with a little bit more of that, then we'll feel like we've gotten something done.
We love Ruby. What we want to do is show you guys how we use Ruby to get stuff done on really short time frames and maybe create some love for Ruby too.
Okay, so one of Ruby's key strengths is that the flexibility I talked about. That flexibility also means that it accommodates and allows for dramatically different coding styles. While this might sound really scary at first, it's actually kind of a cool thing. The three of us have completely and totally different coding styles.
Totally different.
Somehow,
I actually come from a procedural background. Eric comes from a network background.
All over the place, yeah.
Chris comes from an object-oriented background. We all use Ruby to get stuff done.
this is our team. This is our tool of choice for the team, and yet our code, usually with little or no fuss, will work together. And that's one of the unique factors about Ruby that we really love. There are certain rules that we try and adopt and conform to make life easier there too, but by and large, Ruby makes that easier. The other thing I want to say about this is that that variance in style lends itself to, if you want to create a new tool, Ruby's a good prototyping language at the very least. You'll usually find yourself though sticking with your prototype for a longer period of time than you might with something else.
And refactoring Ruby is really easy.
I also wanted to specifically call out something that we're going to talk more about as we go along, which is JRuby. JRuby is notable to us because we all have varying backgrounds, but none of them include a particular love of Java. So JRuby fits this gap for us beautifully, and we'll get into why in more detail later, but specifically it gives you really transparent access to the whole Java runtime and virtual machine, all the classes that you could want. If you've worked with any of this stuff, you know what we're talking about. If not, we'll try and demonstrate some of that. Another kind of common, actually we wanted to call out Ruby Black Bag, which is a tool that sort of evolved from an older tool chain that we used in our team, which was just Black Bag. It was implemented in C. It was sort of more, it was more of a way of doing things and a bunch of tools that enabled you to do that. There's a bunch of like Unix geeks who like to do stuff on the shell command line, and a bunch of tools that made it really easy and flexible to do that, and you could kind of adapt the tools to all kinds of things. This notion carried over when we started using Ruby. We wanted to keep that kind of theme going, so we ported over things from Black Bag like network, plugboard proxies, Blit, Telson, things we'll talk about later too, but you will also see Ruby Black Bag show up all over the place because this is an example of one of those libraries that you write once, you use all over the time, all over the place.
And once you download and start looking through our code on GitHub, you'll realize that we spend a lot of time mixing things in and really abusing the dot method syntax for everything. So we're going to talk about scripted pen testing, and basically what we mean when we say scripted pen testing is having a dynamic tool where when you're looking at something on the wire, and for my example, it's going to be specifically about things happening on the wire, right? You need a tool that you can sit there and for HTTP or for bespoke communications in Java or for Corba or for RMI or for SOAP or for just raw XML going across the wire, you need a tool where you can sit there, get in the middle, look at things, and make sure that when you start understanding it better and fuzzing it, that you can attack it immediately.
And I like to sum up the notion of scripted pen testing is you take pen testing, which is what you do manually. You may use automated tools, but actually the keynote I thought hit very briefly on a subject that kind of is near and dear to me, which is that automation is usually sold as a great thing, but it can also be a bad thing because it can cause you to miss things. That's totally applicable to security testing. So the challenge is that there are tools out there for all kinds of things in security. Why would you want to reinvent the wheel when there's something out there? Well, there's a lot of good reasons. Oftentimes, there's too much automation in the tools that you use. You can't get down and dirty when you need to and get to the details. Some of the things that Mike was talking about, for example, like XML, those sorts of things are abstracted away from you. So you take your normal workflow of pen testing and you want to enable it and enhance it somehow. So you have a dynamic scripting language. This isn't new for Ruby, but again, we already talked about why Ruby suits itself well.
So the very next thing we're going to talk about, even though it says Eric says that you don't have to reinvent the wheel, the very next thing we're going to talk about is actually reinventing the wheel. So when I first came to the team, I didn't really know that much about Ruby. I'm an old guy. I'm an old network testing guy. I come from a Tickle background. I don't know how many of you in here are Tickle fans. I'm a huge Tickle fan. And I basically made the jump straight from Tickle, sort of skipping Python a little bit, and then straight to Ruby when I came here. So what I did was, so I created a tool called, sorry. I'm missing it. Technical difficulty. All right. Oh, here we are. So I created a tool called WWMD. Now, I am pretty much the red-headed stepchild of the team. I love web application penetration testing. I love it. There's a lot of reasons for that. But one of the things that I promised I wasn't going to carp about engagement issues when this slide hit, but there's a lot of logistics challenges that you have to handle when you are assessing a web application. You really need to get an idea of what the application does in order to be able to test it properly. As much as you just want to get in and start fuzzing an app for cross-site scripting and SQL injection and all those other little fun things, the big findings, the findings that the owner of the app is really going to care about are the business logic flaws, are the simple incrementing an integer to get to somebody else's payment card data, right? So Using the tools that I normally use, what I really wanted to have happen was to not have those more subtle vulnerabilities take a back seat during the testing. So I wanted to create a tool that would help me automate and find all the things that are part of the OWASP top 10, and then once I gain an understanding of the app through discovery, go in and find out the more subtle flaws that an automated scanner or the average human isn't going to be able to find.
Yeah, and I like to, think of a lot of what you're talking about too as, in our notes we have, you don't want to miss things, but at the same time, you want to really just dive right in and get straight to the meat of the engagement that you're on. You don't want to spend a lot of time bootstrapping and getting your tools up and running. You just want to dive right in, and if you have a tool that's flexible enough, you can do that.
Yep. So these are the tools that you know and love. If you do web app penetration testing, you've used some subset of these tools. Burp is in bold because we use Burp every day in our practice, and we'll talk about Burp.
We love Burp.
We love Burp. We'll talk about Burp later on. And sorry if you're in the audience and you're a vendor for a product that I missed, I apologize. So why something new? So in my previous life, I've had a lot of success building scrapers and fuzzers to test web applications. And when I say scrapers, I mean, so by fuzzing, I mean injecting inputs into the application from which I expect to get an unexpected result. We'll talk about fuzzing later in the talk. When I talk about scraping, what you want to do with a web app and what you want to do with a lot of fuzzing, and you'll see our approach to fuzzing later in the talk, is you want to actually be able to parse and understand the responses that you get from the application such that when you put in an input that does something damaging, you want to immediately know what the result is. And the way you do that in a web app, or the way you do that in any DOM, XML, period, I've learned since I started writing this app, is XPath. XPath is the most useful thing for scraping. XPath searches are the most useful thing for scraping an HTML DOM you've ever seen in your entire life.
Right. And again, the key here is making sure you're not missing anything, but getting to what you need quickly in the page that you're scraping. So
what it's also good for, so WMD serves two purposes. One is I can sit on the command line and get pages and look at the results and fuzz forms and start looking at SQL injection and all that kind of stuff from an IRB prompt. I can also use the same code that I wrote in that IRB prompt, dump it to a script, and now start automating that same process. One thing that I find really useful with WMD that isn't in the slides is whenever I'm weaponizing something like blind SQL injection, I've seen people do this with with curl and Perl. I've seen people do it with straight Perl. I've seen people do it with Tickle. I've seen people do it with Python. I can sit on the command line and create a method that injects SQL into that injects blindly into SQL injection, and then automate it such that I'm doing the kind of bitwise operations that make blind SQL injection successful, pulling table names and data out of a database. In a simple 20-line Ruby script, I can just make that happen and present it to a client. So next, what does Ruby bring? So for transport, we use curb, which is basically Ruby bindings for libcurl, which everybody, if you've ever done web app pen testing, you know about. Ruby also comes with NetHTTP, an event machine, and a native OpenSSL library. Event machine, if you've ever used Tickle, event machine is like V-Wait. It's the event loop for Ruby, and we're going to talk about that a lot. You will see event machine being a common theme during the rest of this talk. Next. This is a bad idea.
So what we're looking at is how all these things kind of come together in WWMD.
So I'm just going to go over here now. So these are the classes that WWMD presents, right? So the page class is the class that does all the heavy lifting. Basically, page inherits everything that curb does. Plus it provides some convenient methods. Then there's a scraper class, which is built on Nokogiri or Apricot, which are both XML parsers for Ruby. And this is where you get all the useful GUI in the pages. When I'm fuzzing get parameters or headers or forms or whatever, when I get responses back, I want to be able to parse the headers, I want to be able to parse what's in the page, and I want to be able to do that in a way that makes sense, right? So Spider basically is a very simple spider that you can, so we're going to get the code example for this is taking a web app that we know, creating a login method, creating a very simple spider, and then creating I want to say it's a 70% WASP 1.0 compliant XSS fuzzer in 35 lines of Ruby. So that's what we're going to get to when we're done with this, right? So now here's the code. So here's example.com. This is actually running on my laptop. We were actually going to do this as a live demo, but their live demos are way more technically necessary.
This was harder to set up for a demo.
Yeah. So I just decided to put the slides in. So here's the login page for example.com, right? So when we get this page, the first thing we're going to do is we're going to drop to an IRB prompt, get the page, look at what it does. Look at what it does. So we're basically going to go in, get the form, right? We're going to look at the page. We're going to see what the page is. We're going to get the form. So the form has two parameters. One is username, one is password. We know the form type is post, and we know that it posts to loginhandler.php. So next, we're just going to write a script. Sorry. That's all right. So here we're actually going to write the login method. So this is a method that now so this is an example of mixing in. So what I'm doing here is I'm reopening the page class that's part of the WWMD module and adding a login method to the page class. So now, whenever I instantiate a page class, whenever I instantiate a page object, it has a login method. And that login method takes 3 arguments. The argument is the URL to go and get the URL to go and get in order to get the form from a username and a password, right? So the next line, we go out and we get the URL that has the form on it. Then we actually get the form, right? Then we say, well, if this page doesn't have a form, something's wrong. So we're going to return false or raise. You can do either one, right? Now we're going to set the form username and the form password, and we're going to submit the form, right? Now we've just logged into the application. In order to test that we've successfully logged into the application, we're actually just going to naively test whether or not there's still a form with a password field on the screen.
Right. So what Mike's doing here is he's automating the user actions in a browser so that he can simulate those things and send the right request. This isn't necessarily unique to WWMD. There are tools out there, other Ruby libraries. They're less pen testing, security-ish related, though. So what Mike's done with WWMD, though, is he's geared all this stuff to fit into that pen testing workflow much more so than these other tools. Yep. And I think another thing to point out here is, you'll see this other theme in a lot of our how we use Ruby and how we promote Ruby is, you go from IRB to prototyping, testing around, to creating something that you can actually just load into a script or load back into Ruby. And so as you're getting a better understanding of an app, you're producing code, and that code is usable throughout the engagement and then possibly in other engagements. Yep.
So from the little bit of reconnaissance that I did about the login page on IRB, in IRB, I was able to write a login method. And this is really simplistic. There are much more complex things that if you start using tools like this, you're going to end up doing with tools like this.
Right.
And we'll get into examples of that in just a little bit. So this is a script. So this is a script that I wrote that actually just simply instantiates a page object, calls the login method with the correct arguments, and then tells us whether or not we're logged in. And as you can see, the result of the script, which was the XPath search to go in and find the text for you are logged in as JQ public. If you go to the next slide, right, we're scraping what's in the top right-hand corner using XPath, right?
You are logged in as JQ public. Upright.
Yep. So now we know we're successfully logged into the application, right? So the next thing we're going to do is once we actually log into an application, and this is the discovery process, right? The first thing I'm going to do when I'm discovering a web application is log into it. Well, I'm going to connect to it, obviously. Then I'm going to log into it. Then I'm going to start spidering. I'm actually going to start using it as a user would use it. So the next example is to create a very simple spider using the spider class that will go in and get all of the pages to which JQ Public has access. And as you can see, we added 6 lines of Ruby, right? That basically it's just you instantiate a spider, right? And in here we're actually using, when you instantiate a page object, it actually comes with a spider object. So we're going to set it to ignore any URL that has login and logout in it, right? And then all we're going to do is use it like a generator. We're going to shift off spider URLs until we're done. And every time the spider goes to another page, it gathers the links, uniques them against its current list, and adds them to the queue. And you just shift off the queue until it's empty, and now you've spidered the application. It's very simple spider, right? So now that we have a spider, the next thing we want to do is create a very simple cross-site scripting fuzzer. And this is a smart cross-site scripting fuzzer, right? So basically all we do is we load a fuzz list from a file, right? And in this case, the fuzz list is just, script alert one script. That's all we're doing here. So while we're getting URLs from the spider, right? We're going to get the page. We're going to check to see if the page has a form, and we're not fuzzing get parameters here. We're just fuzzing forms. So if the page has a form, then for each element in the form, for each element in the fuzz list, we are going to create a regular expression, which is our fuzz string, right? We're going to create a regular expression for that fuzz string. We're going to submit the page's form with our fuzz string, and if the string gets reflected back on the page just by doing a simple comparison with our regular expression, we know there's reflected cross-site scripting in the page. That's exactly what you do manually. It's exactly what scanners do. It's exactly what Burp Scanner does. It's exactly what Web Inspect does.
It's
right?
also good to point out, I just noticed something here that you're not using XPath. You're using regular expressions, which is kind of a feature. You can switch on and off when you want it. Are you using XPath?
No, I'm using regular expression.
Right.
So all I'm doing
I'm sorry.
So all I'm doing is submitting a form, and if that string comes back reflected in the page, I want to know about it. That's it. And this is a very simple application. So at the bottom is you can see the output from the script. There are 13 fields on here, 2 of which, and this is by design, like I wrote this in PHP, 2 of which by design are susceptible to cross-site scripting. And you can see in the output at the bottom, it found those 2 fields. And that's it. So another thing that's interesting, another thing I did, I don't know, I want to say going on 5 months ago, is I work with .NET apps a lot, and they have view state. And Jeremiah Grossman, I think, said that 4% of view state enabled apps on the net today don't have view state Mac enabled. So what I want to do is write a tool with which, whenever I found one of these 4%, which this tool has become much more useful.
Show of hands, how many people are familiar with what that means, having view state Mac enabled? Okay, so there's a lot of not hands up. So
.NET, go ahead, you do it.
All right, so view state is tricky to do right. Well, I mean, it's something that would sound really insecure. What's happening is the web server's shipping, it's serializing up server-side objects with stuff that if you can modify server variables you shouldn't be able to. And it's handing it off to the client, letting the client hold on to it and send it back when needed. It does it this way to kind of simulate state over HTTP.
Yep. So basically, when you load
so what
up
the Mac is for is to make sure that while you're holding on to it, if you make any modifications, that authentication code.
HMAC. So
yeah, the HMAC actually it still applies to the data. So you need to know a secret key to create the right HMAC for that.
So how many of you in here
this
know
is how
what
they do it
view state
securely.
is?
But if they don't do the HMAC, they're in really big trouble. And this is what he's pointing at.
How many in here actually know what view state is? I'm sorry if I was going way too fast. So view state is basically just a base 64 blob that gets passed in every post to an AS.NET page if it's enabled that contains the state of the current page. And I've seen view states that are 64 megs in size. Developers stick stuff into the state bag they should never stick in there. And one of the things we're going to talk about next is view state has what's called a binary serialized object. I'm going to get to that after this slide. But what I want to be able to do with the view state was to be able to deserialize the view state into a form into which I already know how to fuzz, in this case XML, and then write an XML fuzzer for the view state. And now I have a view state fuzzer. So basically, I get the view state, I turn it into XML, I write a generator to fuzz the XML that's produced, right? And now all I do is submit that page over and over again with a new base 64 encoded view state that I created from my XML. And I do actually, so I can't talk about them, but I do actually have findings because of this, right? But the next thing that's even more important, and where I actually have important findings, is view state has what's called a binary serialized object. What a binary serialized object lets you do is take a custom control, like I don't know how many of you in here have experience with Telerik web controls or anything like that, but they basically shove their state into the view state bag by serializing themselves into their own format, base 64ing it, and then sticking it into a view state node called binary serialized, which then the whole thing is base 64 encoded, and you really can't get to, right? If you look at something like this in Burp's view state decoder, all you get is a great big base 64 string that says type binary serialized, right? What I wanted to be able to do was, in a scripted manner, when I see view state that has binary serialized in it, I wanted to be able to say, for each thing that says binary serialized in here, I'm going to hex dump it out, right? And now, if there's things in that piece of the state bag that are important or that leak sensitive information or that contain state that I want to know about in order to properly inform the rest of my assessment, I know it's there, right? And so with this tool, with 4 lines of Ruby, I can do this in an automated manner. And there's no other tool out there that actually does this for you. You have to spend time.
There's .NET, right?
.NET won't, .NET doesn't do it.
You
have to actually write a
marshal and
.NET
unmarshal stuff into .NET.
But I did this in Ruby, so I don't need .NET to do it.
That's the point, is that we can roll these into the other tools that we have in Ruby. He's using stuff from RBKB there to do the hex dump, for example. So again, it just goes with the whole flow of the tools that you need.
And in .NET, it's way more than 4 lines. I don't know if you've ever written C#, but it's way more than 4 lines.
Okay, so I'll take over here. Another area I guess you're done on WWMD?
Oh, next.
Right, just making sure. Okay, so another area that I liken to the scripted pen testing approach that we thought we could talk a little bit about. We've talked a little bit about it before, but not in a conference or presentation setting, is Java Remote Method Invocation. This is a technology that's been around in Java for well more than a decade. It's almost ubiquitous nowadays in most Java enterprise apps. So we see it all over the place. You probably see it all over the place. The gap that we saw, though, was that there weren't really easy to use or friendlier to use tools out there for testing JRMI apps. There was Nessus, which has had actually this one plugin for a long time that basically can enumerate RMI endpoints, but it doesn't go much further than that, and there are good reasons why. But to be able to, and the reason why is because to be able to actually enumerate RMI and start doing meaningful things with it, you have to have and be able to interact with the RMI stub. So what RMI really is, maybe a definition is an order. It's Java's answer to serializing objects between clients and servers on a network and allowing them to treat them like they're a local, transparently. So when you write an app around RMI, you're creating a binding to a remote interface. From the local code, it doesn't really look like you're doing anything over the network because you're calling methods on an object. What's happening under the scenes is it's using the stub framework and a skeleton framework on the server to kind of remote that call over.
Yeah, they're actually serializing the object, passing it over the wire, and then executing the object on the Java side.
In some cases, it gets kind of hairy.
There's gray areas, but it's another kind of comms just like anything else. Like whenever you see something going, so our approach to assessments of just about everything is if we see it on the wire, we want to be able to screw around with it.
Right.
And this is one of those things.
In this case, though, I wouldn't say we're necessarily screwing around with it on the wire. What we're doing is so historically, the only way to test security on RMI apps is to actually start writing bespoke custom Java code. And as we mentioned, this is not one of our favorite things to do. I've done it for RMI before, but I kept on going, there has got to be a better way out there. So I heard about things like Jython, and I was doing a lot of Ruby. I heard JRuby was awesome. This is probably when I really jumped into JRuby more than anything. And it made me realize just how transparently it seemed like I was writing Java, except for when I didn't want to. I didn't have to do stupid try, catch, blocks, and all the annoying things that come with Java. So the workflow for something like RMI with JRB, which is a good example of the scripted pen testing, again, it follows that model of starting out with IRB, prototyping things. You fire up IRB, JIRB in this case, JRuby's IRB. And you just pull in all of the classes for the target you want. You could be selective. You could just try and find the specific stub classes. You'll know what they are because they're underscore stub. But 9 times out of 10, it's just a matter of pulling them all in at once. They'll be in your namespace. If you need to find them later, you can. But again, we don't want to spend a lot of time dorking around when we can just get to the meat of something. So the code here at the bottom gives an example of enumerating the interfaces, and this works just as well as a script. I think I actually implemented this as a method. I could call from IRB too. It connects to the victim host on port 1099, which is the RMI registry endpoint. This is where RMI endpoints register themselves so they can be visible on the network. It identifies it goes through each endpoint and walks that endpoint. Now, the next step is where you need to have the class loaded. If you don't have the classes loaded, you'll know right away because it'll raise an error. But assuming you have the class loaded, you can now go through all the instance methods, and the code there that's the puts meth2s, it's really small, but actually what it gives you is a Java-looking prototype for each method. It would be it would look just like what you would see in an interface file, for example. And this is kind of cool because this is an example of Ruby taking some of its introspection features, which we didn't really get into too much, but probably should. Applying introspection, Ruby's introspection is awesome. We'll probably talk more about it. But what's really cool with JRuby is it takes all those idioms for introspection and it applies them right into Java. And that's where I was really blown away when I first started doing this stuff. All right, so given that example, what you'll typically find is when you start enumerating those interfaces, and this is the core security risk with RMI, is that it exposes methods that the programmer didn't really think were there or didn't really think about when they put them there. Because of that transparency, it's really easy not to pay attention to security. So you're really likely to find interesting functions exported out by these endpoints and be able to interact with them transparently, like the code you see here.
Yeah, we found leave behinds that were entirely accidental that were real security problems. Yeah. I'm just doing color.
Colorful. All right. So anyway, that kind of wraps up the scripted pen testing. I'm going to hand off now to Chris.
Who hasn't said a word yet, ladies and gentlemen? Chris Rohlf.
Chris Rohlf. Thank you.
Thank you. All right, so when it comes to reverse engineering, what are we talking about? We're talking about reversing undocumented network protocols, executables, binary blobs, things that we don't have any information about. Ruby really helps us here because the tools we write are cross-platform and cross-target. What I mean by cross-target is we can apply the same code and approach from the network protocol that was undocumented to the executable that we're looking at. Okay, so we'll start off with network protocols. One of the best ways to test an unknown protocol is to be the man in the middle, to sort of get in between client and server and see what they're doing and muck with the connection. We use plug boards a lot for this, which is basically a fancy way of saying we use proxies that rewrite connections. The other half of the equation, of course, is developing an understanding of the actual message formats and the protocol that you're talking. Obviously, there could be 30 different fields in a single message. If you only understand 2 of them, you don't really get the whole picture. So 3 tools that come with Black Bag are Blit, Plug, and Telson. And there's some variations of each within Black Bag. We use them frequently to plug board network connections and get in between clients and servers. Telson's a utility that acts kind of like a dumb client. Basically, it's sort of like Netcat. You're going to make a connection to a remote endpoint with Telson, but then on the back end, you can send messages to Telson via Blit that's going to send those messages across the wire. So it's sort of like a Netcat you can talk to out of bounds.
I think the distinction is that Blit lets you kind of isolate and control the messages a little bit more easily than Netcat, because Netcat is more kind of line-oriented. Blit is more blob-oriented, message-oriented.
And basically, so one of the things that we abuse dot methods a lot. So string has a dot blit method when you load Black
Next
Bag.
slide. That's on the next slide.
What's that?
That's on the next slide.
Come down.
Oh.
Plug is a lot like Telson, except it's a proxy. So basically, it just rewrites a connection for you.
So in a nutshell, if you're talking to a server without a client, but you're the client, you want to be the client without any other involvement, you're going to use Telson. If you want a client and want to see what the client is doing and interject messages in the middle of the conversation it's having with a server, you're going to use Plug, which is probably misnamed as plugboard proxy. So just to make that a distinction, Blit is what you use to talk to both. And what Mike was talking about, and this code shows it at the bottom, I'll just dive into that really quick, is that there are 2 versions of Blit. There's the IRB version, which is just an extension on the string class, which you can see at the bottom, PL array. That's just a string, and it's being sent through the Blit out-of-band channel directly from IRB there. The other option is a command line version, which was the holdover from the original Black Bag, so we wanted to keep some of that functionality.
So basically, just to I don't know, I don't want to say dumb it down a little bit, but just to bring it down to its least common denominator, right? We have a proxy running in the middle. We connect a client to one side of the proxy. The proxy connects to the client, and they now have a conversation back and forth. What we do with Blit is, in that channel, we actually blit things into that channel. So we're basically blitting out-of-band things into that connection to see if we can generate a response. And you can actually create fuzzers like this. If you have applications that depend on persistent connections, it's really hard. A lot of times, it's not to fuzz applications that require persistent connections. What I can do with Blit is I can create a persistent connection for my app and then just blit into that and create a fuzzer just using that connection.
Right, so what we're getting at here, in this example, we're actually talking about, so here's an example of a workflow with these tools. You capture a bunch of requests we give the example using PCAP because we wanted to also have that ability, but you might also use the plug board because it's dumping these messages. You can have it log and whatnot. But in this example, we're going to use PCAP. We grab messages as they go along the wire, then we split them out by message, and we create a huge array in Ruby or a small array in Ruby of all these messages that we want to send. Then we start walking through them. We also use these messages as templates for fuzzing. So I'll let you go and talk about Ruckus.
Okay. So Ruckus is kind of like, I don't know if anyone has ever used Ruby's bit struct or bin data. It's a way of declaring binary structures in Ruby, sort of like the way you would do it in C. So Ruckus is meant to be a pretty flexible tool. The more you learn about a protocol, the more you can change your Ruckus structures and, on the fly, and the easier you'll be able to manipulate that protocol. Sorry.
So I mean,
tripped myself up there. So we tried to make something comparable to C structures using a DSL, domain-specific language in Ruby. And we didn't come up with the idea. Things like bin data and bitstruct existed before us, but Ruckus is really an evolution of that idea.
So what we basically have in Ruckus is a way to create notations for protocols as they live on the wire. So it's like, I don't know if you've ever seen the TCP struct, right? It's the same thing, right? What we have with Ruckus is the same thing that when we're sitting around a whiteboard that we write on a whiteboard, we have that same notation, but it's now code, and it's code that marshals and demarshals protocols on the wire.
right. So in former lives and even in current life, we still do some C coding, and oftentimes the notation while you're reversing a protocol is going to look like C structures. However, C structures, there wasn't anything that actually parsed C structures into Ruby, which is why we ended up with Ruckus.
Yeah,
We didn't necessarily invent the idea of that DSL either. That came from bin data and bitstruct, but we like to think that we've evolved Ruckus somewhat and kind of geared it again more towards the security testing workflow.
And when you're building your reversing idea of a protocol on the wire, you say, oh well, that's a uint32 length. I'm gonna declare that as a Ruckus struct, and that's a null terminated string. I'm gonna declare that as a Ruckus struct. That's an int. I'm gonna declare that as a Ruckus
Right.
struct.
So what we end
you
up
just
is
keep on going until you finally reverse the whole protocol into your Ruckus struct.
we end up with an object that encapsulates all the data in binary form that we want to deal with, but we can manipulate it by field. We can change it. We can spit it back out to binary. We can make modifications to the structure on the fly too, which is one of the things that bin data and bitstruct make it harder to do. And then we can create a new binary blob out of it. Or we can do it in reverse. We can start with a structure and kind of compose our own binary object by field. So, go ahead.
So static analysis. Static analysis is when we're trying to reverse something that we don't have access to, the original source code. Black Bag gives us a bunch of tools to help us detect and identify embedded data or streams of data inside those binary blobs, whether they're executables or just data. And again, Black Bag comes in here because it sort of lends itself to our larger scope static analysis projects like disassemblers and that kind of thing. And there's also some built-in methods for pulling out data like hexify and R strings, which is a better Unix strings
So again,
implementation.
a disassembler is an invaluable tool for reverse engineering. So why not make it part of your scripting workflow? So having a disassembler for your scripts is what we're talking about here.
So this brings us to Frasm, which is, so there's this C library out there called DieStorm, which was written by a guy named Gil Daba. Basically, it's an x86 32-bit and 64-bit disassembly library. It comes with a Python extension. We don't code in Python, we code in Ruby. So we naturally wrote a Ruby extension called Frasm.
Because that's how we roll.
How we roll.
All right, so comedy's not going to cut it. All right, never mind, sorry.
So back to static analysis. We can use Ruckus for file format structures too, not just network packets. We need to be able to parse executable file formats like ELF-PE and mock and a dozen others. So a good example of that, we've written Rohlf and Rupi, which are basically PE and ELF parsers in Ruby that work with Frasm and work with some of the other tools that we've developed.
In a lot of ways, they're almost identical, except they have different file format parsers, but they both kind of hook Frasm the same way.
So onto dynamic analysis. Static analysis can really only take us so far. because we're not interacting with the code, we're not interacting with the data on the wire, that kind of thing.
And a lot of times we're going to be when we're doing static analysis, we're going to be decompiling things all the way back into source code anyway. So
yeah, so it helps to bring dynamic analysis into the fold. And what we mean by dynamic analysis in this case is, running code under a debugger and watching what it's doing, watching the functions that are being called. And we developed a tool called Ragweed. Ragweed is basically a cross-platform scriptable debugger that works on Windows, OS X, and Linux.
Right. So personally, before I really, was really into Ruby, my tool of choice for a scriptable debugger was PyDebug, which you guys should definitely check out if you haven't. In addition to Ragweed, I've got a lot of respect for PyDebug. It's kind of what I consider the granddaddy to what we've done with Ragweed. But we wanted something with Ruby that we could wrap in all the other code that we've written. So we ended up with Ragweed. We should probably talk about some of the things that are kind of cool about Ragweed.
You can do some really cool things with Ragweed, like in just a couple of lines of Ruby, write a hit tracer, and for each breakpoint that you set with that hit tracer, you can pass in a Ruby block, which is basically a bunch of Ruby code that's going to be executed when that breakpoint is hit. So we can create really dynamic hit tracers that spew tons of information.
It's teeny, you probably can't see it, but there's like
our screenshot there is
6 or 7 lines of code there.
Debugger.
It's a functional debugger using Ragweed. It doesn't do a whole lot, but kind of illustrates short, succinct code. And the other thing about Ragweed that's really cool, that when we did Ragweed, we created Ragweed implementations for Windows, OS X, and Linux. So we try and maintain this cross-platform approach because we usually do our testing on all kinds of platforms. So, is there more? Yeah. All right, so I'll take over here. Another area I think that's been kind of underutilized is dynamic Java analysis. Look, when the historic and time-honored and excellent tradition for testing and reverse engineering Java is to decompile the code. There are excellent decompilers out there, JAD and Jode being two that I use, and probably JAD more so than Jode. But I have tons of respect for both of them, and I'm not saying stop using those. But I found a gap where I wanted to apply the same kind of scriptable debugging approaches that I would with a native executable to Java targets, mostly to save myself time, because the downside to using just JAD and Jode is that, well, you're kind of screwed if you're dealing with obfuscated code, which we're going to kind of show a little bit of in our demo, but it's not really obfuscated code, but it's something obfuscated. The other thing is that you can screw yourself on a project by decompiling a huge Java application and then spending, God knows how much time pouring through the code. You need a way to pinpoint and hone right in on the classes and methods that you're really interested in, which is what a dynamic scripting debugging hit tracer is going to really, it's kind of why it was designed. Yeah, so there are things out there like Java profiles, there are profilers and so on that do this sort of thing, but none of them really had the features that I wanted. So I ended up with something I call JDI hook.
And again, all those things are written in Java.
Most of them, yeah. And of course, it has the advantage of...
The bullet point there is you don't want to, every time you assess a Java app, you don't want to turn into a source code audit. You really don't want to do that. We've done it before. It's not good.
Okay, so I'm going to have to start typing here. Can you guys hear me?
Oh, I got it. I'll do it.
Okay, so I'm going to give a quick demo here of using JDI hit tracing. Okay, so I've come up with a sort of a somewhat contrived example, but it's based on real experiences of an embeddable or embedded SSH server written in Java. And it has a backdoor, and I want to know what that backdoor is. So I'm going to use a hit tracer to watch actual method invocations, the arguments that get passed to them, and the return values, and quickly hone in on and identify the code I'm interested in and find this information I'm looking for. So it rolls in sort of a slant on obfuscation because, well, the password's going to be obfuscated. So there's the teaser, I just gave away the ending. But, all right, so the first step is we're going to launch our server. Actually, I think I have it running. Can you guys see the text is pretty big there, so you should be able to see that. Okay, so the first step is to find out, to get our target running as a debuggee. So we need to find out the process and do that here. I just want to find the command that I'm looking for, which is somewhere in the process table. So I can see Java running. This is my server here, Ninja SSHD. Don't look too closely because you'll see that I actually wrote half of this exploit, this demo in JRuby itself, which wasn't the point of the talk, but it's because I'm lazy. So once I've identified the Java command line, I want to add two arguments to it, which enable the Java VM running to add features for Java debugging. Those features, the two arguments are just xdebug and then this whole string of JWDP arguments, or JDWP, sorry. So once I've got that, I'm going to kill my first instance, start the new one, and I can tell that it's ready to be debugged because I get this extra message here. So with that running in the background, let's see if I can make this a little bigger. I'm going to try and log in. Just quick, simple test. So trying to log in as foobar at localhost. Doesn't matter what I type in. It's not working. But what I'm doing there is I'm actually firing off a bunch of Java methods inside of the Java VM. And what I want to do is, what I'm going to do is attach a hit tracer to watch those and capture the arguments that get passed around as various methods get called, which is kind of the basis for hit tracing. Java makes it really easy to get access to these arguments and return values though too, which is why this kind of came together nicely. So the script is pretty straightforward. Again, it's really short. I just instantiate an instance of my library object for JDI hook. Then I add some callbacks like Chris was referring to with ragweed as Ruby blocks. I'm sorry, can you guys see that?
We're running short on time. Get
Yeah,
to
I'm
the
trying to run
punchline.
it. All right, so when I run it, I'm going to jump to this part. So the first thing we need to do is identify the username. We'll see how we identify that shortly here. But I'm going to skip the step where I have to do this twice. So I run my hit tracer, adding output to a log file. It's ready to capture, and we can see here a bunch of method invocations. I'm not interested in any of these yet, though, so I want to hone in directly on what I'm interested in. So now I actually do a login, kill my hit tracer, look at my log. What I'm going to look for as my, I guess, bookmark is the username. And I can see at the very bottom of my list a class called lameauthenticator.authenticate, which is being called with the username and password that I supplied. Sorry, this one is all goofy. There. So I logged in with the wrong password, but I can see it right there on the screen. I'm not interested in the wrong password, I'm interested in the right one. So I'm going to look at the code for that. Now I've honed in directly on what I really am interested in for this purpose. When I look at the code, I can see that it's basically, the authenticate is basically taking the username and password that I supplied, comparing the username to a hard-coded string, and taking a hard-coded encrypted password, decrypting it, and comparing that to this string. So there are two ways that I can get at this information now. I want the password. I found out the username because it shows up all over the place in my hit tracer, but the password's trickier. Not that much, though, because first of all, I can see the return value from my hit tracer, in my hit tracer from that invocation. And I can see right off the bat here in the return value, there's the decrypted password coming out of there. So since I have access to all the invocations inside of the JVM and the return values from it, I can get access to things like this. Obviously, the authenticate method that I wrote here was a terrible implementation, but you actually kind of see these kinds of things a lot in real apps. So with that, I'll close off the demo. I just wanted to say a few more things about dynamic Java with reversing. So there are two other things that, well, two other big points I want to just touch on. One is that using JRB, you can actually run JRB as the debuggy and use it to kind of steer the classes you're interested in. This is really useful in honing in on the code you're interested in. The other thing is you can use it to interact with the classes that you're interested in and use it to basically turn the target against itself. So with that, I'm going to turn this over to Chris for fuzzing. Mike, sorry.
That's all right. So we're running short on time. So basically, when we say fuzzing, what we mean is, and in the business, everybody knows that fuzzing is fault injection testing, right? But when we say fuzzing, what we do is we try to go from the dumbest fuzzers you can make to smart surgical fuzzers that are fuzzing specific spots in requests and messages with specific strings to generate specific results, right? And that's basically what this part of the talk's about.
Right. So we start dumb, move on to something a little bit better, and we got to give a nod to Dino here because we talked about defuzz, which is something that we use a lot that Dino wrote.
So we basically start with a 3-line stupid Ruby fuzzer that just injects.
Let's just skip to the intelligent stuff.
Yeah. All right. So now we're at the intelligent stuff.
Intelligent fuzzing. Back to Ruckus. Ruckus has built-in mutators. So you define your protocols, and then you take individual fields within that protocol, and you define mutators on those fields. So quick example down the bottom, we have a string. We create a mutator, a multiplier mutator, and give it a character A. And every time we call string.permute, it's going to increase the length of that string.
Yeah, the generator here is not particularly useful, but it illustrates how you would use it. It's just a growing string.
And as you can see from the top of the actual protocol, the size of that string is directly related to the length of that string, and Ruckus automatically would fill that in for you. So it's kind of where the intelligent part comes in. ActiveX controls are another really ripe area for fuzzing where we find lots of vulnerabilities. And Ruby has Win32 OLE for parsing COM objects. Basically, to fuzz ActiveX using Ruby, what we're going to do is use Win32 OLE to enumerate all the methods and properties in a COM object and the type arguments to those methods. And then in maybe 50 lines of Ruby, we can create a fake web server that starts to fuzz those controls intelligently based on type arguments and all the good information that was given to us by Win32 OLE.
So we were going to do a demo. I'm just going to launch it and show you guys it running. It's not that exciting.
It's exciting when you find something.
It is. This also might take down my laptop because...
You're welcome.
Yeah, thanks. So we start up a little web server and then we connect to it. This is actually, it works a lot the same way that I think Axeman, HD Moore's Axeman does, in that it starts up its own little web server and then just keeps on giving you redirects.
Yeah, so Axrug knows the type of arguments that this method takes. So it gives it a string when that argument is a string, and it gives it an integer when that argument is an integer.
Right, so here we're just using that kind of somewhat lame, but although sometimes really effective, growing AAA string and feeding it in. Okay, so back to the slides. Let's see if we can try and knock out some more of this talk. Cool. All right, so another big kind of area that we see and we use Ruby a lot for is kind of bringing in other tools into the Ruby fold, I like to say. Maybe that you guys would describe it a different way. But there are three big areas. One is wrapping external C libraries. This is the conventional and usual way to do it. The other areas are
embedding Ruby in existing tools that really suck and need scripting capabilities. And of course, there's JRuby, which Eric went on and on and on about.
JRuby is weird because it's so seamless. It doesn't really seem like you're wrapping a library, but you actually are.
So quick examples of this. We had an old tool, QFuzz, basically written in C for fuzzing network traffic in line. But again, fuzzing in C is really, really painful. So we embedded a Ruby interpreter. And this sort of takes the blit plug Telson idea and kind of brings it down to a kernel level and hooks like TCP sessions completely in line, transparently, bumping the wire, and then you can fuzz those connections and that data with Ruby. Another example is LeafRub, which is Leaf is an ELF analysis framework written in C, but it's extendable with
By
plugins.
Chris Rohlf.
But
Thank you. Basically just wrote a plugin that embeds Ruby interpreter so you can do all this static code analysis in Ruby, not C. So you can do it in half the time.
So we're actually out of time. So we're going to make sure that you guys can get to the rest of your talks. If you guys have any questions about this stuff, find us after and ask us. We also have a couple more slides that talk about a couple more tools.
This is the last slide, so I'll just close
especially
up.
Booby.
Booby's great. You know, we said we love Burp. So kind of like Chris had tools which he actually wrote and then decided he wanted to make more Ruby. There was a tool that we all used a lot, and I said we need more Ruby in Burp. That's it. We got to do this. So it was actually really easy with JRuby. I was going to go into some of the design and stuff, but I'll just leave it at that. You should check out these tools. We've got most, if not all of them, out on GitHub. Check out Monti, Mike Tracy, and Struct.
And the rest of the team too. They're all out there too.
That's true.
So if you have any questions, hit us up. I'll be downstairs drinking beer.
And we'll be here for a couple of minutes too. Feel free to come up.
Yeah.
Thanks a lot. Sorry we went.
But I
Thank
will
you.
be
Just a
downstairs
little
drinking beer.
Thank you.
Thanks, everybody. And everybody who walked out, you didn't get to see the last slide, so neener.